How is the Reynolds number calculated? Well, use the formula, right? And it really is that simple. Let's look at the answer here. Now, it does mention here the general formula where dH is a hydraulic diameter, which is defined to be 4 times the area divided by the perimeter of the cross section of a flow. Let's check that out. So if we're talking about like a pipe, right? Let me try to draw a circle here, which could be dangerous because when I draw them on the fly, they usually turn out horrible. Could be worse. Okay, but if we look at that and we're thinking about, okay, hydraulic diameter, so I'll write d sub h, and it says there 4 times the area. So 4 times, now let's see, the area in terms of radius, right, for a circular cross-section of this pipe would be pi r squared divided by the perimeter. And since the perimeter, right, 2 pi r would be the circumference of that circle, which is really the perimeter of it. And you can see that some cancellations happen there, and we would simply get 2r by that definition. So that really shows the connection between the definition of this hydraulic diameter and the formula for Reynolds number of a pipe that we've suggested we're going to use. But the key thing to know for all these is that rho represents fluid density, V maybe is obvious, that is fluid speed, and that eta is the fluid viscosity. So in that sense, how is it calculated? Well, if you're looking at a specific example, you need to look for these numbers or ways to get to them in order to calculate a Reynolds number.